Hey everyone, this is Mr. Schultz, and I'm here with Inequalities Day 2. We're going to be taking a look at compound inequalities. So to do this, I just want to show you kind of a real-life situation of where these come in and why we are doing them. So it says this: when fishing for walleye in Minnesota, there are only certain size fish that can be kept. So for example, all walleye that are less than 18 inches must be released. So if I'm going to draw that as a graph, I'm just going to go to my 18 inches, and I'm going to put an open circle because it doesn't include that. It says less than 18 inches. So anything smaller than 18 inches. Smaller than 18 inches must be released. But then also all walleye that are greater than 24 inches must be released. So then I'm going to go over to my graph here, and I'm going to go to 24 inches, and I'm going to say that those also have to be released. So then when you think about that as one graph, it's going to look something like this. So what's that saying is that, any fish that is less than 18 or greater than 24 needs to be released. So it's one thing or the other. That's what that or statement means, is basically it fits either this condition or it fits this side of the condition. I think that the or statement here kind of looks like rowboat oars, O-A-R. So that's just a way that my brain thinks about it. There's nothing that's mathematical about that. That's just how my weird brain works. Let's go on to the next part here. So compound inequalities. We've got two types here. We talked about the first one already. It's this or one. It's saying that x is less than or equal to -3, or x is greater than 2. That would be like this situation that we see right here, or on the walleye one. We had the less than 18 or greater than 24. But we also have a quality that is called an and statement. And so an and statement just means that both of the conditions need to be met. So in this case, both of them need to be met, not one or the other. So in this case, you can write these as one big long string and put x in the middle and say that x has to be bigger than a -1 and less than 2. So you can also write it as kind of one long string like that. You don't want to do that with your or statement, because it's not that both things have to be true. And statement means both things have to be true. So that could be something like if you're riding a roller coaster and it says you have to be at least 48 inches to ride this, but you can't be taller than 72 inches. So what that means is that if you're 50, you are between 48 and 72, allows you to ride the roller coaster. So our two types are the and the or statements there. So writing the and or statements for this situation, so I'd say that x in this case is going to be less than a +4. And I know it's going to be an open dot because it's less than it, so it's not the equal to, but it needs to be smaller than 4. 3 is smaller than 4, so you can always plug that in, check it. Or x should be greater than or equal to, because it's a filled in dot, 9. I know this isn't or because it's kind of creating those rowboat oars there. So one of those two things. My second one, this is going to be an and statement because it's kind of got the connecting line here. So I'm going to put x in the middle, and I'm going to say that it's going to be, x is going to be greater than or equal to, +7 is one of my boundary points here. And I'm going to say that x is going to be less than a -1. Oh, excuse me, this is a -7 here. So x is going to be greater than or equal to a -7, and x is going to be less than a -1. So this is how you'd write the two compound inequalities there. If you want to rewrite this one as two separate things and say and just like you do with the or statement, that's perfectly fine with me as well. Doesn't matter which way you write it. Now let's see how we do these when we start to solve them. So when we start to solve them, they actually solve the exact same way. So here, I'm just going to solve them the exact same way we saw yesterday, which was you just set up and solve. So I would just say take away 4, just like that. But since this is an and statement, I'm not just taking away 4 from one side. I need to take it away from kind of both pieces. So this is just how my brain thinks about it, is I'm taking away 4 from both of those sides. So I'm going to take away 4 from a 12, which is going to be equal to 8, and it's going to be equal to -9 when I take it away from 5. So my 2 points here, my 2 boundary points are going to be at -9 and positive 8. I'm not sure if I counted that right, but it doesn't really matter too much. And both these are open dots here, so I just have to figure out and test my points and say, okay, which way is my direction going? So let's test 0 because it's right in the middle, and it's a pretty easy point to test. So I'm just going to plug in a 0 here. So 0 plus 4 is 4. Is 4 going to be, is 4 going to be bigger than a negative 5, but less than a positive 12? That is true. It checks out. So I know my line should be going this way. It should check out. If you want to, you can obviously check out 2 points beyond there too, just to make sure. But it does look something like that. Let's go on to question B here. So now this one, same type of thing. I'm just going to go ahead and set up and solve and find the boundary point first. So I'm going to take off 4 from both sides, get to 9. Got negative 3, so I'm going to divide by negative 3. X is going to be, one of my boundary points is going to be at negative 3. Then I'm going to do the other side here. So 12 divided by 3. X is my other boundary point is going to be equal at positive 4. So I'm going to put positive 4 and I'm going to put negative 3. Again, I'm not really counting to see what the exact distance is here. I suppose I could. This would be a negative 2, negative 1, 0, 1, 2, 3. So 4 should be one more over. Should be something like that. Should probably try to be more accurate with it, but doesn't matter that much. Let's see, where did I actually have that? Right here. Okay, so now I just need to figure out where does the boundary point, or where do these go? So my first one, the negative 3 one, this will be a filled-in point because it's got the line underneath it. This will be an open point, and then I just need to figure out where is my line going to go. So let's start with the 0 point, so negative 2, negative 1, and then 0. Just check it out and see if it works. So I'm going to plug in a 0 here, which is going to make that be 0. So is 4 greater than or equal to 13? That is not true. You can also check it on the other side to be sure. So 5 is greater than 17. That is not true. So we know it doesn't go here, which most likely means we should be making this OR statement like this. But let's check it with one more point. So let's try 5. So I'm going to go through and I'm going to plug in 5 now. I'm going to create some space. So negative 3 times by a positive 5 is negative 15. Plus 4 would be negative 11. That's definitely not greater than or equal to 13. But remember, this is an OR statement. So it's one or the other. So it didn't work on that side. So I'm going to try it on the other side now. 3 times by 5 is 15. Plus 5 is equal to 20. 20 is greater than 17. This does check out here. So we know that this does work because it needs to work on either this side or this side. It does work here, so I know that I have drawn my lines in the correct spot here. So my final answer is that it should look something like this. Let's go try another couple here. So let's try another OR statement because these are the ones that tend to kind of throw us off a little bit here. So pause the video and try this one out here. All right, here we go. Let's go ahead and solve this here. Find our boundary points. That looks like a 3. So it'd be a positive 4, and I've got a negative 4x. So I'm going to divide by my negative 4. X is going to be equal to negative 1. And then on the other side, I'm just going to divide by my 3. I'll get that x is equal to a negative 3. So my two boundary points are at negative 1 and negative 3. And it looks like the negative 3 point is going to be a filled-in point, and the negative 1 point is going to be an open point. So now I just have to figure out where are my lines going to go. Since it's an OR statement, I'm assuming that it's going to go here, but I want to check my work and make sure that I'm doing it correctly. So I'm going to try negative 2. So if I plug in a negative 2 in for x, I've got positive 8 plus 2 would be 10. 10 is not less than 6, so it doesn't work there. And then I'm going to try it on the other side. 3 times by a negative 2 would be negative 6. Negative 6 is not less than or equal to negative 9. It is greater than. It doesn't work there. It both doesn't work in this section. So I've tested my point. It should work out. Of course, best case is you would test a point on this side or this side as well to confirm. But it didn't work in the middle, so it looks like I'm doing okay. Let's move on to the next one here. Same type of thing. Except this time, remember, if I do it, make sure to do it to everything that's happening here. So I've got an AND statement, so I've got to add that 6 to both sides. So I've got 10, I've got my negative 5x's left, and I've got my 35 over here. going to divide by a -5 on everything, absolutely everything. So I've got my two boundary points coming at -2 and -7. So I'm going to put my first one at -7. Then I've got 6, 5, 4, 3, 2. And it looks like my -7 boundary point is going to have a filled in dot because I've got the line underneath it there. And this is going to be an open dot because I don't have a line underneath it there. So again, now I'm just going to test which of these spots is my line going to go. Because it looks like this, I'm assuming it's an and statement, but let's test it and confirm what's going to happen. So I'm going to choose a number here. I don't know, let's try -5. 5s tend to be simple to go with here. So I'm going to say a -5 times by my x, which is a -5. That'd be a positive 25. When I take away 6 from that, I'm left with 19. So is 19 greater than 4? Yep, it does check out there. And is 19 less than or equal to 29? Yes, it is. So it does work here. It does check out. So both of these probably do not work, and you should be good to go. Again, you can just plug in a point from either side here and check it out. Last thing here, when I'm choosing a point, I'm just trying to choose a point that's in between here. You actually could try and use -7, and it should in theory work because it should be less than or equal to. But you can choose any point in between here as your point to test. I'm just trying to choose a simple number. So I like to choose 5s, 0s, 2s, things like that that just are pretty straightforward math. Sometimes when I choose things like a 7, like 7s just kind of throw me off sometimes. Nothing wrong with them, but I'm just not as fast like with that. So I'm trying to choose a little bit of an easier number there. So in summary here, here's what's going on. If you're solving an OR statement, you should be making these rowboat ORs when you test your points. When you're solving an AND statement, you should be making that kind of bench, is the way that I call it, just to keep with that rowboat theme when you test your points. But remember, OR statements, it's one or the other. It shouldn't be both of them. It should not be true in both of them. But if it's an AND statement, it does need to be true in both. It needs to be true in both pieces here. In an OR statement, it's true in one side or the other side. That's what that means, this or that. All right, that's everything that I've got for you today. Have a good rest of your day.